Thanks so much, Todd, for this opportunity. So I'm Edward, founder of StudentRND. And you guys are all here today because you're innovators. You're here to hear from and talk with future innovators in the technology industry. And that's just awesome. So give yourselves a round of applause for attending this event. Now, today we've been hearing about the future of shopping and the future of entertainment and gaming. I'm here to talk about the future generation of technologists because StudentRND helps create the next generation of technologists by getting students to work on tech projects in their spare time. And primarily, this is actually through an event we run currently in 5 cities across the country called Code Day. It's a 24-hour marathon where we get high school and college students to get together, and they pitch ideas, form teams, and build something they think is awesome over the course of 24 hours. A cool app, a cool game, a cool website, and then they present it to each other at the end. And it's just really incredible. A year ago, we were just in Seattle, and now we're in 5 cities. So in the next year, we're bringing this to more and more cities, and we're still looking for partners. So if you're interested, do come and talk to me or go search up StudentRND. But for today, I'm here to talk really about StudentRND Labs, which is our summer program. And over the summer, we invite passionate, motivated high school and college students to our offices over in Bellevue to co-work with us and work on a cool project that they think is awesome. So they spent their entire summer really self-directed, working on an interesting project. And we've seen some really cool things come out of it. For example, this summer we had this one team build a robot that could actually automatically track and shoot at targets with a Nerf gun. Another team was working on wirelessly charging your phone so that you don't actually have to plug in your phone anymore. You can just set it on your desk and it will start automatically charging. Here today, we brought 2 teams to present what they did over the summer. And one of them, the first one, is Helpful Machines. And they're a group of students that's innovating and revolutionizing the calculators. And the second team is SciSub, which is a team of high school students that are working to build an after-school program for middle school students to learn more about technology. So this presentation really isn't about me, it's about the students. So without further ado, I'd like to invite up Noah Litov and also Blaze Ritchie from Helpful Machines.
Hi, I'm Noah Litov. I am a high school senior at the Northwest School in Capitol Hill, and I'm a hardware designer.
I'm Blaze Ritchie. I go to South Seattle Community College, and I'm a software developer.
And together we are co-founders of Helpful Machines.
And the creators of the Calculator, a graphing calculator for the modern world.
So we designed the calculator together over the summer from the ground up, both hardware and software, designing with students, professionals, and hobbyists in mind.
So, why did we make the calculator? So I'm here to talk about the future to you, but bear with me for a moment as I talk about the year 1996. In 1996, you could buy a computer along these lines. Maybe not quite along these lines, but you get the picture. Today, we're more accustomed to computers like this, with over 10 times the processing capabilities and consume about 1/100th of the power. In 1996, you could get a cell phone, which did one thing: it called other phones. Today, we're more accustomed to smartphones. And really, the word phone for this device is a little bit of a misnomer, as it's more of a computer. In 1996, you could get a Texas Instruments graphing calculator, which did everything you would expect a graphing calculator to do in 1996. Today, you can still get these graphing calculators, but they do everything you would expect them to do in 1996. This is what the calculator fixes.
So now that we've told you why we made the calculator, let me tell you a little bit more about its hardware. The calculator is built on open source hardware, which makes it easy for students and hobbyists to modify or hack it so it has a broad spectrum of ability to fit any need. In addition, it has a sleek but durable ABS plastic case to protect the hardware within, making it usable in any number of situations. But perhaps its most interesting feature is it has not one, but 2 high-color, high-quality touchscreen displays. The first acts like you might imagine any other display to show the data and, like a smartphone, can be used to navigate the operating system. However, the second display is a little bit more interesting. It's a technology designed specifically with this product in mind. The calculator has a panel of clear buttons on the front, tactile buttons. Underneath those sits the second display. When a button is pressed, it sends a signal through the display to the processor, acting like you might imagine any button to. However, because it has a display, the button layout is completely customizable, allowing you the flexibility you would expect from a modern mobile device. Below that, there's very little to separate the user from the internal hardware and the rechargeable battery, making it very easy to hardware hack. So you may ask yourself, why wouldn't I just get an app on my smartphone, for example? Let me tell you in one word: hardware. Having dedicated hardware device is invaluable for a number of reasons. First and foremost, as I mentioned before, we have tactile buttons. Having tactile buttons increases the efficiency and the accuracy of data entry. And since there is no real spell check for numbers, a computer can't figure out what you want to enter. And so it's invaluable to have a precise system. In addition, a student might not be able to bring a mobile device such as a tablet or a smartphone into their classroom for a number of reasons. But having a dedicated hardware device specifically for this purpose allows them the flexibility to use for at home and in the classroom.
So I developed the operating system for the calculator, which is built entirely from scratch, which accomplishes not only the tasks that current graphing calculators accomplish, but also things for engineers and higher level math classes such as 3D graphing, symbolic manipulation, and scripting abilities. Here's an example of what the operating system looks like. Here you see we have a menu featuring a list of apps, the graphing screen, which is interactable with the touch screen, and a home screen for entering math expressions and one-line scripting.
So what's next for the calculator? We decided to take the project to Kickstarter. As students, it's very hard for us to find funding, and so Kickstarter is a perfect opportunity for us to gain the publicity we need for the product, as well as the initial funding to begin production and complete development. This will allow us to bring our product to fruition. Okay, not quite that type of fruition, something a little more like this. So, thank you very much for listening to our presentation. We hope you will come up to us and talk to us about it, because we only have 5 minutes, and so we can only fit in so much, and we're more than happy to talk to any one of you about ourselves, our product, or our company. In addition, we have a website, and we hope you'll go to the website and sign up so you can find out and get information as we continue and finish development of the calculator. Thank you very much.
Next up, I would like to introduce the team SciSub, who they're a group of students from Interlake High School and also Eastside Catholic, who are working to build a next generation after-school program for middle school students.
Hi, I'm Jiawen. I'm a senior at Interlake High School.
I'm CJ Kindle. I'm a senior at Eastside Catholic High School.
And I'm Tanvi. I'm also a senior at Interlake High School.
Okay, so we're SciSub, an after-school program for middle school students. We teach science by building submersibles with these middle school students. Submersibles are like submarines, but simpler. Keeping in mind that what we do is we teach science, we decided to organize our presentation in the format of a lab report. As with any lab report, we had a question that we wanted to investigate. And ours was, how come students aren't enabled to bridge the gap between middle school and high school science?
In researching this question, we noticed one thing. If you ask a student, how do you measure this characteristic of this water sample? They'll say, well, you stick a sensor in it, and it gives you numbers, and you write them down. Obviously, this is a problem. So our hypothesis of why students aren't making this leap from middle school to high school science is because They believe that sensors are these magic black boxes, and they're not truly understanding what that data means. And this is hindering them from really being successful in science, and it's discouraging them from pursuing science in the future.
Subsequently, we predicted that if students were given the opportunity to build their own sensors, they would gain a deeper understanding of the data they collect and also be able to put that data into context.
So what we did was we designed a submersible. It contains our sensors and a microcontroller, which sends the data back up to the surface. Our sensors are housed inside of small film canisters. Not only are these very cheap and accessible, we also are teaching middle schoolers what film canisters are. The other parts of the sensors, for example, are turbidity or water clarity sensor, which is just one of many sensors, has an LED on one end and a light sensor on the other. As the water flows inside of the film canister, it blocks some of the light. This decrease in a reading is a direct result of the water clarity levels. So the students can really understand what that data means. They understand that the blocked light is what causes the reading.
And so as SciSub, our job is to solve this problem where students are not contextualizing the data that they're seeing in their science classrooms or in any science experiment that they perform. And the way we're doing this is that we spent our summer making this after-school program where we build these submersibles with students, and then we guide them through a full investigative lab so that they can understand the very basic level of where their data is coming from and really, really, truly understand the meaning of what that data means. And in the future, we are planning our first pilot in a few weeks in the fall with 6 students in the hope of really expanding more into the spring with different iterations of the program.
Now, for our data, to continue our experiment, to see it to its end, we need your support. Donate at scisub.org or check us out on Facebook, find out what we're about. And additionally, refer our program to students who you think might be interested in really putting their science education or taking it to the next level.
Thank you.